Okay, I want to look at how we would go about simplifying the difference quotient for a function like this. Let's suppose we've got the square root of x. And we want to simplify the difference quotient. We want to use the definition of a derivative to find the derivative. Okay, so in other words, here's what we've got. F prime is going to be equal to the limit as h goes to 0. Now, I've got to put in the f of x plus h. Well, f of x plus h is going to be the square root of, instead of x, I've got x plus h. Okay? So there is f of x plus h, now minus the square root of x, minus my function, all over h. Now the question is, well, how do we simplify this? How do we evaluate this limit? Because certainly if we plug in 0 in for h, we get 0 over 0. Well, what we're going to use is a trick. Remember that when we have something like a minus b times a plus b, and we multiply these out, what we get when it's all said and done is just the first term squared minus the second term squared. And you could verify that by just, multiplying this out. Well, if we have the square root of a minus the square root of b times the square root of a plus the square root of b, well, we get, just like up here, we get the first term squared minus the second. But in this case, we're squaring a square root. So what that's going to give us is a minus b. Now notice the radical is completely gone. So what we did there, the trick that we're going to use is we're going to multiply this by its conjugate. So let me show you what I'm talking about. We've got the limit as h goes to 0, and we're going to take this thing, the square root of x plus h minus the square root of x all over h, and we're going to multiply the top and the bottom by the conjugate. The conjugate. Okay, the conjugate of the square root of x plus h minus the square root of x. And what the conjugate is when we change the sign of between these two radicals. So instead of the square root of x plus h minus the square root of x, we're going to take the square root of x plus h plus the square root of x. And we're going to multiply the top and the bottom by that. Yeah, like this. Now, when we do that, what we get is the top is just going to be, and remember to carry along your limit, what you're going to get up top is just the first term squared, which is x plus h, right? The square root of x plus h squared is just x plus h, minus the square of the second. The square of the square root of x squared, the square of the square root of x is just x, like that. Now down here in the bottom we get something a little more complicated because, we've got all this big mess down here. Not really too big of a mess, but it's not as nice as the top. Okay, so there's what we have. Now, the top simplifies nicely because the x's cancel. We have the positive x and the negative x here. So now let's dig what we have. We have the limit as h goes to 0 of h over h times the square root of x plus h plus the square root of x. Well, this is cool because notice that h cancels. That's really cool because now what we have is a situation where it seems like we are set up to evaluate the limit. We've got the limit as h goes to 0 of 1 over the square root of x plus h plus the square root of x. And, well, if h goes to 0, what you get then is 1 over the square root of x plus the square root of x. Yeah, just letting h go to 0, and that will give us 1 over 2 square roots of x. Ah, perfect. So we found the derivative. This is the derivative, f prime of x, provided that f of x is equal to the square root of x. So we found the derivative, and the key was to multiplying by the conjugate. Okay, so let's look at another one like that. Let's suppose that f of x is equal to, let's suppose we've got x plus 4, something like that. So here we go. The derivative is going to be the limit as h goes to 0 of, here we go now, x plus h plus 4. Notice I'm just putting an x plus h in place of x minus the square root of x plus 4. See? All over h. See? Just, this is f of x plus h here, and this is f of x here. Now, I want to multiply by the conjugate. So here I go. I have the limit as h goes to 0. Always carry along your limit until you actually evaluate it. So here's x plus h plus 4 minus x plus 4 over h. And now we're remembering, we're multiplying this whole thing. That whole thing we're multiplying by the square root of x plus h plus 4 plus the square root of x plus 4. It's like we're multiplying by 1, right? Yeah, there we go. There we go. And we're taking the limit of this whole thing right here, right? Okay. So no harm in doing that, but what it does, it makes it so that now we could write this in a way that doesn't have the radical up top. So up top we've got x plus h plus 4 minus, now be careful, because here's where you can make a mistake. You don't want to write just x plus 4 up there. No, it's this whole thing, right? The first thing squared minus the second thing squared, and this whole second thing. So the negative applies to the x plus 4, the entirety of it. But down here you've got this thing. You've got h times the square root of x plus h plus 4 plus the square root of x plus 4. There we go. There. Okay. Now just a wee bit of simplifying. So here we go. We've got the limit as h goes to 0, and now look at this. Let me go ahead and write it out. X plus h plus 4 minus x minus 4 all over this bottom. I hate to write it out. It just takes a minute. X plus h plus 4 plus the square root of x plus 4. Okay, there we go. That wasn't so bad. Okay, now the next line, we're about done with this one. Okay, so here we go. Notice these x's cancel, the 4's cancel, and look at this. We've got the h here, which is going to cancel with this h down here. So let me just write this as 1 over the square root of x plus h plus 4. Notice I haven't evaluated the limit yet, so I'm just keeping it. All I've done is kind of simplified. See? I've just kind of simplified it. Now I'm ready to evaluate it. If I replace h with 0, what I get is 1 over x plus 4 plus, well, the square root of x plus 4 plus the square root of x plus 4. And there's a couple of those, so I just write 1 over 2 square root of x plus 4. There, and there's your derivative. So that's the way you can use the difference quotient to get at the derivative of these things with radicals.